Thank you, Ken. I pass the mic to you.
Okay, thank you very much, Felix. So first of all, thank you very much for inviting me to give this sharing to the audience. So my presentation topic is Redesign the construction value chain for reduced embodied carbon. This is the content page. And then first of all, I would like to give an introduction about the embodied carbons. Embodied carbons is all the greenhouse gas emissions relates to the building constructions. At the bottom part of this page shows the cradle to grave embodied carbon. There is a three parts, it's divided. The first is the cradle to gate embodied carbon, which include the extraction of materials and manufacturing and construction. And the second part is the operational carbon, and after all, it is the end of life of carbon, which is include the demolitions, disposal, or recycled carbon emission. And this is the construction value chain. The construction value chain is include many parties involved, and like the investor or the property developer. And sure, there is main contractor, and then there is some architects in the construction value chain. But I will focus these four tiles in my presentation. And there are many ways to reduce embodied carbons, such as new technology like digitalization, electrification, and we can revamp or rearrange the workflow, such as MIC, and innovation is an important part of to reducing the embodied carbon. And the compliance of green standards or green certificates is one of the important parts that can reduce the embodied carbon. If it is green buildings, we can join the green building certificates such as BEAM Plus, LEED, or China Green Building labels. If it is a material, there is some material certificates scheme like CIC Green Product Scheme. So after all, you have to track your result to view is it you're on track, your embodied carbon is on track. Digitalization is one of the most important parts recently in construction. I can say BIM. In other words, it is a digital chains of construction buildings. It is important when it is widely adopted in our construction site. Here is the BIM in the building life cycles. The design, material supply, construction, and operation team utilize BIM and facilitate their works. For example, the architects can use BIM for design development, and then the contractor can build the buildings by following the BIM. I will give another examples to show how BIM can get involved in embodied carbon. Here is the example for solar studies in different seasons. The pictures in the middle shows the sunlight can be captured in summer times, and the pictures at the bottoms stimulates the sunlight in winter times. This can help the structural design, such as the location of the planter, the fins, or the window size. BIM is a good tool to demonstrate the construction sequence. We can use BIMs to compute movie and examples to demonstrate the construction sequence to the project teams. Here is an example of installation of the main truss in Kaida Sport Park. The main truss is a huge steel structures. BIMs can stimulate and visualize the work sequence. It can be easier, it can be more easy to understand for the project teams. In the BIM models, we can trial the logistic and lifting of the main truss. If you're interested, you can scan the QR code to see how project teams install these trucks. Beam Cave. Beam Cave is a virtual mock-up. The project teams can use VR to see the illustration of the complete project. The project teams can walk through and reach anywhere in the VR models. So as a result, there is no physical mock-up is needed. Eventually, this can save many things, such as manpower, times, logistic, energy, or eventually the material can be saved. Material fabrication is one of the important things that BIMs can do. You can see on the top left corner, there is building structures. The geometry or the shape is irregular. If BIM can translate the 3D models to 2D drawings for material fabrications, this can make the fabrications works more precise. As a result, the wastage of materials can be minimized. During the construction stage, it is a big problem for construction team that the building surface, the surfaces works and the building structures may clash together. So BIM can help to find out all clashes and then propose the best methods to avoid it. So this can eventually is to avoid the abortive works and double handling and material wastage. To be concluded, BIM can save many things, such as manpower, time, equipment, logistic, material, and energy. Eventually, the cost and embodied carbons can be saved. The next part, I will discuss about the electrification in construction site. It is the decarbonization strategy for us too. The concept behind is very simple. Just use less fossil fuel, use more electricity. This is our principle. But something we need to note it. So what we should do before we can use less fossil fuel or use more electricity. So we should ensure the availability of the grid electricity before we start the project. As a result, we should prepare the application for the grid electricity earlier. And what we have to do is to phase out the fossil fuel-driven construction equipment. But there is some limitation. The grid electricity may not be available at some remote construction site, or if it is available. But sometimes the power supply is not enough for our construction plants to use. And something we are concerned is about the availability or the cost of the electrical plants. Here is a real depicts the grid electricity to supply powers to our construction project. If the two power companies in Hong Kong is provide the grid electricity to us, after that it enter to our site, there is two questions. If the grid electricity is good enough, so we can be used by our plant. But if the grid electricity is not enough, a battery energy storage system, I will call it BESS afterwards, is required as an intermediate solutions to replace a diesel generator. So traditionally, if power supply is not enough, our diesel generator will be deployed for on-site power supply. But BESS is work as a power bank to storage electricity and supply when necessary. It is designed to replace diesel generator. BESS is very good performance for tower crane and hoist in construction site. But there is some limitation for the BESS. BESS cannot serve all types, some types of construction works, such as continuous welding during the foundation stage. We have conducted many trials with the suppliers. We found that the usage of BESS can be optimized for 3 tower cranes in the best case. So as a result, one BESS can replace 3 diesel generators, we can conclude. And we support BESS very much. You can see this is the real pictures we take in our construction site. There is 17 BESS we used in our construction site. Using BESS not only to save the fuel, it can also save the carbon emission. Okay, the next part I will go through the smart system in mobile electricity. I will call it SSME afterwards. So sometimes the power supply the power supply by the grid electricity is not available or not enough. So use diesel generator becomes unavoidable in our construction site. SSME can minimize the usage of diesel generator. SSME connects generators to form a mini power stations. It regulates and distributes electricity through a local network. The number of units of generators switch on depends on the power usage. And recently, we deployed 5 sets of this SSME in our project. SSME can also save fuels and also save the carbon emissions in our construction site. And we have to do some things about the container, because there is many container office in our construction site. So we have to think more, how can we save the carbon by using the container office. We have redesigned the container office with some green features, such as installation of PV panel on the top, and then installation of the insulation lining on the wall. All these things can help us to reduce the consumption of electricity of the container. Eventually, we hope that we can balance, because there is a PV panel on the top, and then the container consumes energy. We hope that we can balance, but eventually we can't do it. But it still generates some renewable energy, and then the carbon emission is safe. And our company have do some R&D for the new material. We call it Capsule Concrete. We have partnering with an innovation and technology company for R&D of Capsule Concrete. First, I would like to introduce what is the normal lightweight concrete. The strength of lightweight concrete normally is relatively low. It cannot be used as a structural concrete. But the new product, Capsule Concrete, is 30% lighter than normal concrete, and it can reduce in mass of superstructure. As a result, the design of the foundation can be reduced too. Eventually, the embodied carbon of the total structure can be reduced. This Capsule Concrete has been successfully applied in one government project, and we get some IP in China, Hong Kong, and US. And the next part is I want to discuss is the logistic management. Traditionally, this depicts the logistic management when a project have some material or equipment they do not want to hold anymore. For such as project A, it will be transported to the warehouse first, and then waiting for some projects request for it. If project B wants it, project B will get the material from warehouse. About the inner material. Inner material, normally we call it is soil or broken concrete or rocks. Normally, the project A will transfer the inner materials to the government field bank first. If there is a project request for the inner material, project B will transfer the material from the field bank. So you can see that usually there is a middleman for the material and equipment transfer. What we think is we want to design mobile apps as digital platforms to replace the middleman. To cater these situations, we aim to provide a digital platforms for projects to exchange the unwanted materials and equipment. This mobile app we have developed already. It is work like carousel. Unwanted material can be matched for project A and project B. automatically after they input their request. However, unfortunately, this app is only for our project use internally at this stage. We have not open to public. But if there is some other inner material, there is another way. We call it alternative disposal ground. We will find other alternative disposal ground if there is excessive unwanted material that we cannot absorb. So last but not least, I would like to share is about the carbon offset program. Although fuel-driven vehicles is now migrates to electric vehicle recently, fuel-driven vehicle is still the majority. You can consider to join the carbon offset programs for your fleet. We have over 100 vehicles join these programs, and the carbon emissions from the logistics can be offset. Every year, the fuel companies will give you certificates to tell you how much carbon you have offset in these years. So my sharing is over here.
Thank you, Ken.
Yeah.
Yeah. Thank you for your for your sharing. You give us a lot of option and alternative in reducing embodied carbon. Especially, I'm very interested in your digital platform.
Yeah.
For material exchange. It is very useful to reduce those kind of transportation emission.
Yeah.
And then have you estimated the money saving and emission saving on this kind of application?
Yes, I have estimate, but I don't have the data on hand now.
Okay.
But we have do some estimations. The cost savings can be around 60% or 70% if you put the inner materials to the government fuel bank. Because you need to pay money to the government, right?
Okay.
And then there is a transportation fee, or if there is a matching from project A to project B directly, only one transportation is involved in this exchange, I will call it. And then there may be some benefit for both projects because you don't need to dump your soil. And then project B do not need to buy the soil from the supplier.
Okay, that's good. I mean, it has been one for how long? It is not. There is some things we have to think is about the matching the date because the program of each project is not the same. Okay. The project A wants to dump their material, but maybe project B is not wants the material at that moment. So the time for the logistic is important. So if more projects join this platform, the synergy effect will become more. Okay. Could this platform be used for sharing or pooling of equipment? Yeah. I suppose not all the equipment are used in every site every day. Yeah. And some of the equipment will be idle some days or some time. Instead of idle, would it be possible that you have this kind of resources sharing or pooling platform such that ultimately you can reduce the total equipment to reduce those kind of purchase of equipment? This is a good idea. Okay. And then we have considered, but we do it internally. Because if we do it, we open to public or other main contractor to use. There is some commercial consideration on this, and but if within our company, we can relocate the equipment efficiently through the platform. Yes. Okay, that's good. Hope that you can. This kind of initiative can also drive down your embodied carbon. Yes, thank you. Okay, and you have talked about the construction value change at the very beginning only on page 4, and in fact, to reduce the carbon, what do you think is which part or which stage is the most important or most challenging in Hong Kong environment? For me, it should be the construction stage for me, because the embodied carbon most come from the construction material, such as concrete and the rebar. These two materials contributes the most embodied carbons in the buildings, and the other parts is this one. Operation carbon is one of the main part to contribute the embodied carbons. But for me, the challenging is how to reduce the embodied carbon or the carbon emission in the construction stage. There is many research or many other green group to initiate, such as the science-based targets to drive the companies to the carbon net zero. So for us, the scope 3 is difficult to control.
Yeah.
So this is our problem, and scope 3, I think it is include the construction material.
Yes, and very interesting. There is at the very beginning of this webinar, we have invited speaker from manufacturer of concrete, manufacturer of cement, and also some academic background. And similarly, they have point out that they have taken a lot of effort to change. That means to adopt those kind of, or to adopt or invent those kind of low carbon material. But somehow they feel that the culture of maybe the designer, the owner, or the construction, that means the user in Hong Kong are still rather conservative in using those kind of so-called low carbon alternative. That means it will be very important that, as you mentioned, all those kind of designer, you are one of the user. It's very important in making the change, to the cultural change, to adopt those kind of low carbon material. Otherwise, the result may not be so satisfactory.
Yeah, I agree.
Yeah, okay.
Because I think the culture is one point and the cost is the second point. The cost will be raised if, I think, simply speaking, if we use lower carbon concrete, the cost is rise, and the construction cost will rise. So is it feasible for the developer or the owner to absorb the cost? So I think here is the problems we need to solve, or there is a long way we need to educate all the people in Hong Kong, the user.
Maybe we need some more pioneer. Yeah, because my background is procurement. In my past experience is procurement. Many years ago, recycled paper is expensive. Yeah, but because not many people buy recycled paper, because it's very expensive. But when more people try to use recycled paper, that is overall there is an economic scale in building up. That is somehow we do need some a quick buyer like you, a quick pioneer like you, to try to initiate, drive down or produce some kind of economic scale. It might help to drive down the cost. Yeah. For those kind of SME, it's very difficult for them to change. As you mentioned, cost is very challenging at this moment. But don't forget about the social cost. I think you are also from the sustainability background. It will be good. Yeah, you have created a lot of insight initiative already. Yeah,
for sure. I will do this.
Thank you. Yeah, thank you for your sharing.
Okay, thank you very much.
And thank you for your time.
Thank you.
Yeah, thank you for your effort. And it's come to the end of our webinar today. Yeah, because our last speaker, Ms. Eagle Mo, she is not available to attend this to present And I have some. Thank you everyone for attending today's webinar. Today, we have listened to different speakers from academic, manufacturing, supplier, recycler, consultant, and contractor in the building and construction industry. They have shared different insight, opportunity, challenge, and experience in reducing embodied carbon. In fact, I have learned a lot from them. Once again, thank you for their time and effort